Today we go on to underwater systems. And then myself and Karin with us for the schedule. One is underwater systems. So this is chapter names of the whole textbook, and chapter 7 is for the underwater system. Summarize. Then I will cover the history and manned system. And second part of lecture will cover the unmanned systems. Unmanned is popular nowadays. Drone. A subsea drone is also. We started from manned drones. So say how many years? 500 years ago. From Italy. We were about diving bell. As I explained to you that this old part was diving bell was no membrane at the bottom. It's a water. That's water. But it's a kept air is there. Kept air is there. So we just people are staying in the air, but pressure is high because of the water pressure is same as water pressure. So depending on the depth of the water, the air pressure is high. But for the human body, there is a limitation for breathing on compressed air. That's why the scuba diving device has a regulating small device to lower down the compressed air. So it is a limitation there. But anyway, depending on the person. So it's a high pressure inside the bell. 400 years ago, there's called the submarine started. And 300 years ago, diving chamber. Looks like this one. Looks like this one, diving chamber. And then 300 years ago, United States, there's a one-man hand-powered submarine. Oh, it looks like this. Hand-powered, one-man submarine. And 200 years ago, hand-powered submarine. Something like this one. So there is a history already. 500 years ago, people are trying to see the underwater world. And then torpedo. Torpedo is appeared 150 years ago. Okay. First automatic torpedo, like this one. And around 100 years ago, first on the sea boat, U1. U2 was famous in World War II. U2. U1 is probably previous one. Looks like this one. Built by Germany. And this year, you need to know that this is World War I and World War II is the stage there around 30 years. But there is because of the war, there is a major advances in technology. Not only underwater, but also air and tank and all the weapons are coming. So also together with the submarines and underwater communication took place during World War I and II. And 90 years ago, Betsy Spear, looks like this one. And that is for the very deep water investigation, something like 1,000 meters on board. Submarine is usually operating around several hundred meters, not so deep. waters because they don't need to do such a, because submarine is for Navy better. They want to win the enemy and win the occupation of the territory, not for investigating deep down to the deep ocean. So it's different mission. So submarines want to hiding from the enemy vessel, and then they want to attack enemy vessel. That is the mission for them. So they don't need to do 1,000 meters. So this is for the scientific observation. 60 years ago, first modern scuba. We already see this picture. And then first nuclear submarine, very early, Nautilus. You need to know that this is the first application of a nuclear power, or other than atomic bomb. First application for, how can I say? It is still military, but not for explosion. So it generates electricity. But this is a first case. Not so after that they found that, oh, it is working, then we can use it in the domestic power. So they are trying to test their ideas as a power generating device, as a nuclear. So it's very historical invention or technology for that. And also there is a research on submersibles. This is deep water scientific ones. And then ROV. ROV is the unmanned one, right? Underwater habitat is for the apartment. And in underwater living quarter for domestic. And then also the suit looks like this one. It is for very similar to space ships in aerospace, far away from the Earth. But as I told you before, that the pressure is different. This one is trying to protect human from the outside pressure because down deep water pressure is high. Right? But in space, out of the Earth, and it is protecting person from the inside pressure, or because there is no pressure outside. Trying to maintain the proper pressure inside the suit, but the pressure direction is different. But shell is very similar. Then untethered autonomous underwater. We will see in the next slide. So ROV and AUV is a two different parts of unmanned one. But this one is highlighted because tethering is important. Difference between tethering is a cable to the vessel. So there is no cable. 30 years ago, commercial AUV, and then glider. Oh, this is glider. Glider is same as air glider, it's underwater glider. So, manned system, not unmanned system, manned system as atmospheric pressure or ambient pressure. Ambient pressure means it can be a high pressure, deep water. The scuba, old style diving bell, and diver propulsion vehicle is old style. They should work with high pressure. Well, atmospheric pressure is one good pressure for human body. So submarine, submersible, sea sphere, atmospheric suit, and then underwater habitat. They maintaining the normal pressure inside, protecting human body. from the high pressure. Lung volumes, our breathing device, lung. See that you can see that this is a milliliter, so that you can see the cc. And our lung capacity is around 6,000 milliliters. Good, right? Big, 6 liter capacity when you use 100%. But usually you use only small portion of your lung as a normal breathing time. So you can say tidal volume. And then if you have a deep breath, then can you say about 70% of your lung capacity? Usually not so much. And there is a residual volume. If you squeeze down your lung out, you cannot make it as zero, right? Because of your bone chest. And you need to know about when you are studying or training on scuba diving, you need to know about this. So deep diving depths of diving training, 12 meters. It is a recreational diving limit for the tourist, and also 12 years old, younger generation, you need to, or beginners, there is a limitation. And also 18 meters and 30 meters is a recommended recreational diving limit for divers, trained divers. And then it can create something like body problem like nitrogen narcosis. And then 65 meters, 100 and 200 and so, and there is a compressed air. You can use compressed air for this meat. And then there's a danger of oxygen toxicity. And scuba diving has a history record of 150, very deep. And saturation diving is another technology for human body, where the Seoul ship for Korean student, the submerged Seoul was around this area. That's why the divers has a problem. Also, another problem was tidal speed. It was up to 6 meters per second. But divers are saying that 1 meter per second is usually the limit of tidal. So 6 meters is very fast for the tidal speed. That's why, one day they can dive only 2 hours per day, because there are tidal oscillation, and between oscillation there is a calm, no speed. There is only 1 hour and 1 hour period. And so that diving was created only that section of time. In that case, diving hazard, there is a 3 main respiratory problems: carbon dioxide excess, oxygen shortage, oxygen poisoning also. Too much oxygen or too small oxygen, too much carbon. So there are so many complicated ones. I cannot explain all this. You should know all this. So there is a breathing equipment like a regulator because of pressure regulation, and then closed, city, open, closed, semi-closed means the air is circulating inside or is breathing out. The scuba usually you need to breathing out, so the bubbles are going outside. So this is an open type. But if you have a closed circuit, then you don't have no bubbles coming from your bubble. So they need to treat again to recirculate that. There are also other type of diving hazard, decompression sickness. inert gas nitrogen process. So one thing I want to explain this is speed of right. Say this way. When you have a Coca-Cola or something like that, you open the bottle, then there is a gas is coming out from the liquid. Right? So inside the liquid, the gas was inside the liquid, but because the pressure is less when you open, then the gases started bubbling from the liquid to the air. Right? Very similar to this. When the body is pressed, when we are in deep water, all pressure is on human body, same as blood, right? So inside blood, more air is melted down because of the pressure. But if you're coming up, then pressure is lower, then there is a coming a bubble inside the blood. That is the problem of this. So they are saying the speed of coming up should be lower, very low. So when you go down there, but you are no air, no oxygen, something, right? So you hurry or something happens. So shark is coming or something like that. You want to go in high speed, it's not good. You need to take time slowly so the body can adapt. There is another diving bell. Nowadays, diving bell looks like this. The new modern diving bell, so that pressure is very good here inside. But anyway, you need outside there's high pressure, inside there's a normal pressure, so that you need to have a time to adapt to inside too. Same. Right? You cannot, you should not go directly into the roof. Same as a bubbling problem. Right? You need to take time to adapt to the pressure change your body. Submarines. 장보고 class is for Korean. Now 장보고 generation 3 is almost finished construction, and that has a 3,000 ton. And this one is diesel engine. And original design is coming from Germany, but now Koreans learns much because already built many such diesel engine submarine for more than 20 years. Now they are saying they can design their own submarines. So they are trying to export submarines from their own design. And so, this one is another Korean second class, and third class is 3,000 tons. And this one is from Typhoon from Russia. The size, see, this is the United States, the size, the big one and smaller, but we see that smaller one, Koreans are using diesel, but the other big one use nuclear power. Why? You need to know this. Diesel submarines are used to propel the submarine on the surface and to charge electrical storage batteries. There are so many batteries here. What diesel engine is used for making electricity charge in the battery. Very similar to hybrid car nowadays. Right? Engine is for charging. Oh, hybrid car is also using the engine for driving too. Right? But this one, separate. Diesel engine is only for charging. The underwater, they use only battery electricity. So propeller is used, rotated by electrical motors. Why? Because their engine needs air. Another reason, and it's quiet. The noise is very important for the submarine. enemy is trying to detect the submarine. Where is the submarine? Each other. Where is the enemy submarine? So sound is the only device to find out the enemy vessel, especially the submarine. So sound level is very important. The diesel engine, noisy, right? Noisy. Explosion inside. Electrical motor, it's good, good. So noise is coming from propeller. And also the water skin, something like that. Water pressure change. Also, answer that we need to have air to operate the diesel engine. So this is also problem for diesel engine submarine, so that they cannot stay longer inside the submerged because of the battery capacity. So we need the air so that probably once a day or something like that, we need to get onto the surface to generate electricity. But nowadays, where is it? The hydrogen fuel cell is used for extend their underwater stay for the submarine. Fuel cell, it's good, but it is expensive. Right? But for the Navy, it's okay. Right? They can use expensive devices if they can stay longer underwater. Right? So nowadays, they are saying they can stay about a week using fuel cell. So technology is advancing nowadays. That's why in old days they use a nuclear submarine. There is no need to surface actually for the nuclear submarine. Energy is the source of, they can generate oxygen by using electricity to use water to make oxygen substance, and also treat CO2 to eliminate CO2 or compress CO2. So nuclear submarine can divide more than the depths, right? And the travel over 60,000 nautical miles before exhausting initial nuclear fuels. It's a very long stay. That is the most important thing, because detection of submarine is very difficult because there is no scanning device, no radar. Only sonar is used only for detecting submarines. That's why most important thing is they want to stay submerged for a long time. And that is the reason why they use nuclear power. But currently, the only problem of surfacing into the air is human mental problems, social problems. So the US Navy has a limitation of 1 month of stay. No, they need to circulate human power. But in emergency cases, they can stay more. I don't know what is the rule. Okay.
A submarine has a sleek cigar-shaped body that enables it to move swiftly underwater. A pressure hull made of high-strength metal contains the submarine's crew, machinery, and most or all weapons, preventing them from being crushed by the pressure of the water at deep depth. A submarine has tanks built into the bow and stern called the main ballast tanks. The sections of the bow and stern containing the tanks are not usually surrounded by a pressure hull. In order for the submarine to dive, the main ballast tanks are flooded with seawater. The added weight causes the ship to lose its ability to stay on the surface of the water, and it submerges. Movable surfaces on the outside of the submarine control its movement beneath the water. These surfaces are horizontal diving planes and vertical rudders at the stern, and a forward set of diving planes either on the bow or on the sail structure. To dive, the diving planes at the stern are tilted down. As the submarine is propelled forward, the flow of water over the tilted planes causes the submarine to glide downward. The rudders steer the ship. Crewmen can turn a rudder to the left or right to make the submarine change course. To move the submarine upward, the stern diving planes are angled up. The diving planes at the bow or sail are used to help keep the submarine at a precise depth while near the surface, especially when launching missiles or when raising an antenna or periscope above the surface. To resurface, water is blown out of the ballast tanks by compressed air so that the submarine comes up through the water.
So, submarine, when submerged, is very similar to airplane. Right? Operation of a submarine is very similar to airplane. You need to have some wing tips operation for down and up, and then tail rudder, or rotation. Change direction. But when you want to get on the above the surface, you need to have a weight difference. And then the weight ratio is very similar to human body. Human body is almost similar to water specific ratio, specific weight. Submarine too. Once submerged, should be very similar to the specific weight of the water. Then we can neutral buoyancy. Then you can use propeller and control plates to as airplanes. Any question? No, we may have too much left. And then non-military submarines and submersibles. That is for tourists. Usually these are tourists. The other one is for scientific. We already see this one. This is a Shinkai from Japan. 6,000 means 6,000 meter down to the river. Design because how much pressure there? 6,000 meter. 600. 18. 600 times then the air pressure here. Big. So that you need to have a very thick steel plate. Otherwise, it can collapse. Limited service range means because they don't need to have a long widespread, but anyway, mainly because of the powering, the electricity or battery or such a. Otherwise, you need to have a cable. But cable also have a limitation of length. That's why they have a limited size. Good. No question. All right. And we can move on to